Alright. Hi guys. I do apologize for lack of uploads. Like I said, I've been really busy. Um, in this video, I want to look at this limit. And this is a trigonometric limit, and this is mostly for Cal 1. So if you're in Cal 1, you know. We have the limit as theta approaches pi over 2 of sine squared of 2 theta over 1 minus sine squared of theta. Now, just to verify, this will give us an indeterminate form, so I'm just gonna kind of just, show you all that really quick so that we understand that this does give us 0 over 0, which is indeterminate. And so we have, it's going to be sine of theta squared over, and it's going to be 1 minus, 1 minus sine of 2 theta squared over 1 minus sine squared of theta. And so if I plug in pi over 2 by direct substitution, we get sine squared of 2 times pi over 2. And then this is all squared, right? And then over, then we have 1 minus, and it's going to be sine of pi over 2. Sine of pi over 2 quantity squared. So I'm writing it that way, guys, so that you'll understand how to evaluate that. And so then this is going to give me, and actually, I'm sorry, this is supposed to be sine of 2 times pi over 2 quantity squared, excuse me. So then we have sine of 2 times pi over 2 is pi, and this entire thing is squared, and then over, we have 1 minus sine, so sine of pi over 2 again is, sine of pi over 2 is 1, so 1 squared, and so then this gives me 0 squared over 1 minus 1, which is 0 over 0, which means, oh no, right, so I just wanted to verify that yes, this is an indeterminate form. Now, we rewrite the limit as theta approaches pi over 2, and it's going to be of the following. It'll be the following. So we know that it's going to be like sine of 2 theta quantity squared over 1 minus sine squared of theta, which is really going to be, and if y'all remember from trig identities, the double angle identity, I'm going to write that down really quick. Sine of 2 theta is equal to 2 sine theta cosine theta. And so we're going to put that in for the sine of 2 theta. So we have 2 sine theta cosine of theta. And this is all squared. And then over. And remember that from the Pythagorean identity, I'm just going to write this down really quick. So remember from the Pythagorean identity, which is, this part, we can figure out what 1 minus sine squared theta is. So if we, again, and I'm showing this, guys, for those that just don't remember their trig. I know that I don't have to do this, but, So we have cosine squared of theta is 1 minus sine squared theta. So we're going to put that in for this, okay? Now, this is going to give me, so like I said, this is this part, and so this becomes cosine squared of theta. And so this is going to give me 4, and we're going to just square everything. So 4 sine squared of theta cosine squared of theta all over cosine squared theta. Okay, guys. And so then we can see very clearly that the cosine squared theta will cancel out, and this gives me 4 sine squared of theta. And so the limit, we are going to go ahead and just evaluate the limit again by direct substitution. The limit as theta approaches pi over 2 of 4 sine squared of theta. We're going to do direct substitution again. This is going to be 4 times sine of pi over 2 quantity squared. And so, like I said, we're just direct substituting here, so direct substitution. And we know that according to the unit circle, the sine of pi over 2 is 1, so remember that sine of pi over 2 is 1. So we know that this is going to be 4 times 1 quantity squared, which will be 4. So thus, the limit as theta approaches pi over 2 of sine squared of 2 theta over 1 minus sine squared theta is equal to 4. Okay, guys, so that is how we do this problem. That is going to be it for this video. If anybody has any questions whatsoever, please let me know. And also, thank you so much for watching, and please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.